The engineer's terms for vibration is vibration occurs when the weight of a rotating equipment is not equally distributed. The heavy point attempts to continue moving in a straight line. The resulting force attempts to pull the assembly outside its rotational axis. The assembly then orbits what would be the normal center of rotation, causing the vibration. But when simplified, vibration occurs in a spinning object when the object becomes unbalanced, meaning it's heavier on one side. The additional weight on one side throws the center of the balance off and makes the rotation lopsided. As this lopsided weight continues to travel in a circle, it causes a wobble, which is vibration.
There are a variety of causes, but in industries, the most common include improper installation, poor shaft alignment, poor quality of bearing, damaged bearings, loose or worn component in the assembly.
The rewards of measuring vibration in an equipment is we get to determine the condition or health of an equipment. We also get to maintain peak performance of an equipment. We get to prevent the equipment from breaking down. We also get to maintain overall quality of an equipment, but most importantly is we get to know when exactly we have to perform a maintenance task on an equipment. Sitting beside me is a vibration testing bench. The purpose of this plan is to measure vibration of three different pumps. The process involved in this plan is, first of all, we have water circulation. The reason we choose water circulation as our process is to relate our project to larger industries that also involve water circulation in their process, such as water treatment or power plants or chemical plants. After that, we have the vibration measurement process. We take the vibration so that we can know the condition of each pump. That's actually our purpose of our project. After we conducted the vibration measuring process, we will then conduct the last step, which is troubleshooting process and maintenance checklist creation.
Okay, so for today's process, once you open the manual and you press pump, press the push button and you go first. From here, once you press the button, pump 1 will have a 3-second delay, whereas the solenoid valve and the control valve will open first. After 3 seconds, the water will go through the pump, and the pump will definitely discharge the water going upwards. So once the tank is full, the float sensor will automatically move upwards, and once it hit the maximum, it will hit on. Once that's on, it will open the solenoid valve button, and it will flushes all the water into the main tank.
Alright, after Aaron explained how the process works, so I'll be explaining on the purpose of the pumps here, the purpose of these three pumps here. So the first pump, the problem that we already applied to this is by having a clog pipe. That's why we have a control valve here. So we can determine, we can change the opening of the control valve. So if say it's 50%, then it's 50% clog lah. If it's 100%, then it's full open. So now for the second pump, aka our master pump, we have a problem called softwood, which you can see here is a metal shim. So this shim is to reduce the vibration, thus make it better. It's one of the maintenance, the shim. And for the third pump here, the problem is bearing. So most probably this is gonna have the highest vibration data. among all three of these pumps. That's all for the pump.
Vibration value cannot be measured by normal human senses, which is why we have decided to use a tool to measure the vibration on 3 different pumps. Just simply hold the sensor into your hand and place it on top of the pump. The sensor will then measure the vibration value and the pump condition will be shown in the table as shown above.